Thank you, and good afternoon. I'm going to talk about accessibility. Accessibility is something that covers a lot of areas. Design, layout, graphics, language, but it's also something that happens at the code level and in the browser, and that's the part of accessibility I want to talk to you about today. Accessibility mechanics are the important ways in which code and the browser work together with assistive technologies like screen readers for people who are blind, screen magnifiers for people who are partially sighted, and speech recognition tools for people who use voice commands to control their technology. The story begins with platform accessibility APIs. Every platform has one. Windows has 3, in fact, at the moment. There is NS Accessibility Protocol on OS X, IA2 on Linux and Windows, UI automation, and MSAA on Windows as well. And these APIs are not like the APIs that you're used to. This is not a JavaScript API. You can't use it as a developer. But the assistive technologies can use it to get at information in the operating system and in the browser. So if we look at a control in a platform, in an operating system like Windows 10, this checkbox, if we look at it with the accessibility APIs for the platform, tells us that it has a role of checkbox. That's its purpose, that's what it does. It has a label of bold because that's what this checkbox does. It toggles a bold text on or off. And it's something that can be focused on. It is focused on at the moment, and it's also checked. So it tells us something about the state. And that information is picked up by assistive technologies and conveyed to the user. If we create the same thing in HTML code in the browser, the same API will return the same information to the assistive technology. It has a role of checkbox, a label of bold, and it's focusable, focused, and checked. And the relationship between these two things, between controls that you find in the application and the operating system, and those that we create in websites and web applications, are mapped by the W3C in an HTML mapping guide. So if you want to know what something you are creating on the web looks like in accessibility terms, that's a pretty good place to start. So I'm going to try and play you a couple of audio example slides now to show you how a screen reader that someone who is blind would use picks up on some of the HTML information that you just code.
Link heading level 1. Proposed Aria password role heading level 2 link. Using the Aria application role heading level 2 link.
So that's just a web page that uses headings and links, really easy, really standard HTML. And the screen reader just picks up that information. It knew what level each of the headings was. It knew that the links were inside the headings, and it knew what the text of the link was. And all that information was just announced by the screen reader because it picks it up from the browser. Here's another example using HTML's sectioning elements, header and main, and so on.
Banner. Main region. Proposed Aria password role article. Search region. Navigation region.
So as I say, just using HTML's sectioning elements, the screen reader has a lot of information available to it. Screen readers are also able to use these elements to navigate by. So it's no longer necessary to read a page from top to bottom. You can just now navigate from one of these landmark elements to the next, and it makes navigation through content much easier than it ever used to be. There are a couple of exceptions to the HTML elements that you can use that will make useful information available, and they are the div and span elements. They're pretty weak in terms of accessible information. If you use either of them, there is very little or no accessibility information made available about them. And that's really critical when it comes to developing particularly custom interfaces, custom controls, or increasingly new web components using custom elements in the Shadow DOM. What happens in the browser is, as Non was saying, you get the DOM tree that kicks in as part of the rendering engine. It's the hierarchical representation of all the objects in the page. What you might not know is that the browser also takes some of the information in the DOM and creates an accessibility tree. The accessibility tree is also hierarchical, and it contains accessibility objects. And these objects will tell you about the role and the name or the label of all the objects on the page, and if it's appropriate, the state of those different bits and pieces. And it's this accessibility tree that assistive technologies will query using those platform accessibility APIs. So when we manipulate the DOM, the browser creates the DOM when it first gets the code, and it then creates the accessibility tree. If the DOM gets updated, either through user interaction or scripted reaction, then the DOM gets rebuilt, the accessibility tree gets rebuilt. Assistive technologies are listening for change events in the accessibility tree, and when they recognize something has changed, they'll relay that information to the user using, if it's a screen reader, speech, like we just heard. So with HTML, if you use it, you get a lot of accessibility for free, which is the best kind of accessibility. You get focus where it's needed. So if you use a keyboard instead of a mouse, you can focus on something when you need to interact with it. If it's an interactive element, like a link or a button or a form field, then that interaction is provided. You can use the space or the enter keys or the arrow keys to interact with it. And you also get that semantic information. This is a heading, this is a paragraph, this is a link. All of those bits and pieces come for free because the browser does it for you. You don't have to do anything to get that accessibility. We don't do that, of course, because we use JavaScript frameworks that don't necessarily take that HTML-first approach. We're building, as I say, custom widgets and controls and elements, perhaps because something doesn't exist in HTML to begin with. So there are lots of reasons why we might need to go back in and build some of that accessibility in. And I'm going to start by showing you probably the worst case example I can think of, and that's creating an entirely custom link, which is craziness, but people do it. If you're curious, you can head over and see this design pattern at the URL that's on screen. But the basic HTML is just a span, using the HTML5 data attribute in place of the href attribute, and we've just got some link text, or what will become link text, in the middle of the span. Now, you'll remember that I say a span has pretty much no accessible information available about it. So if we just imagine now that we had coded it up and we'd given it a bit of functionality and a bit of styling, this is how our pseudo link might work. So far, so good, it seems. If you happen to use a keyboard, this is how our pseudo link would work. It doesn't. You can't focus on a span, because you don't get that free with a span, because it's not an interactive element. You can't therefore interact with it if you use a keyboard. And so pretty much this is no use to anybody who doesn't use a mouse. And when you think about all the different devices and inputs and outputs there are, speech, keyboard, that's pretty much a bad idea. So we can go about fixing it. We can add the Tabindex attribute. You can give Tabindex several different types of value. In this case, we're going to use 0, because that will make this element focusable with a keyboard at the point where the element appears in the DOM. You can use positive numbers with Tabindex to force a particular position in the tab sequence. It's a really bad idea. It's a bad idea for users, and it's a bad idea for developers, because it makes interface management really complicated. But 0 just does the natural thing and adds something into the keyboard sequence exactly where it's supposed to be. We're going to add some focus styles. It's helpful when you put a mouse over a link to know that that's where your pointer is, in case you need a bit of an extra visual cue beyond the mouse pointer. If you use a keyboard, you don't have the mouse pointer, so it's absolutely essential that you duplicate those visual styles so that someone using a keyboard knows exactly where their focus is before they try activating the link. We're going to then use some Aria, accessible rich internet applications, to give it its full name, specifically the role attribute. And we're going to use the role attribute with the value of link. And this is going to change how this span is represented in the accessibility tree. In the DOM, it's still going to be a span, but in the accessibility tree, it's now going to be portrayed as a link. And that's what assistive technologies will think this control now is. We're going to add some event listeners in, just listening for keyboard and click. And in the case of the keyboard, we listen for the key down because we need to capture a key code. You remember I said that if you use HTML, native HTML properly, you get interaction for free. Well, the span has no interaction, so we have to provide it. And in this case, we have to pretend it's a real link. And those you can activate with the enter key. So we listen for the key code for the enter key and use that as the trigger for keyboard interaction. Then we just add some basic functionality. We just get this thing to behave as though it were a link using the content of the data link attribute in place of the href. So, So now there's a screen reader demo again, so some audio, which hopefully will do the trick. And this is now how our link will work, not only with a keyboard, but with a keyboard and screen reader.
Page tab. Tab. Tink UK link. Tab.
So that's just someone hitting the tab key to move on to the link. We can now focus on it. Screen reader identifies this as a link and reads out the link text. And to most intents and purposes, it still behaves like a link. It doesn't do a whole bunch of stuff. You don't get the right-click menu, you don't get status bar updates or any of the other things you get with an HTML link. So really the advice here is for best accessibility, if you can, just use HTML. It sounds crazy, but if we created that custom link, there's about 80% more code than if we just used the anchor element. I don't know about you, but I generally can't be bothered to go to all those lengths when there's a perfectly good HTML element that'll do all the hard work for me. So let's look at another design pattern now, one for a toggle tip, an idea developed by my friend and colleague Steve Faulkner at the Pass Yellow group. And this is an idea to solve the problem when you need to provide inline help or useful information, but you don't want to take up a lot of screen space by having that content inline. So we're going to start with some basic HTML, just another span for our control and a couple of divs containing what will become the useful content area. So if we just look at this in the way that you would use it with a mouse, it goes something like this. So you just hit the button, click on the button, the useful information pops up, and trust me, that is useful information. And you can read it and then just close the button again, and it all gets tucked away neatly in terms of your screen real estate. If you use it with a keyboard, you probably won't be surprised to discover we've got exactly the same problem that we had with our link. You can't focus on it, you can't do anything with it, so we have to start repairing it. And again, we start with Tabindex. When you're creating custom controls of any kind, Tabindex really is your friend. It's your first thing you should think about. You've got to provide that focus. So again, we're using Tabindex 0 to put it in the keyboard sequence naturally. We're going to add some focus styles for exactly the same reason as before, because the keyboard user needs to know when they're focused on the button. So far, so good. We're going to add some role attributes, several of them this time. We're going to use a role of button on the span because it characteristically is going to behave like a button and it looks like a button. We're going to add a role of complementary onto the div that will contain the useful information because complementary information seems like a pretty good description of the purpose of this. And we're going to add a role of tooltip to the content just inside of that, because this shares a lot of characteristics with a common tooltip design pattern. We're then going to use another Aria attribute, Aria-expanded, and we're going to put that on the button. Aria-expanded will communicate the state of this widget to a screen reader user. So we set it to false initially because the whole thing is closed. So when a screen reader user focuses on the button, they're told that this widget is in a collapsed state. So there's something made available to them that indicates that if they use this button, something's likely to expand. We also add aria-described by onto the button. This is useful because while the toggle tip is open, if a screen reader user moves away from the content that's visually displayed and returns to the button, this attribute means that the contents of the useful information will be read automatically to them. They don't have to go back through and actually find the visually displayed content on the page. It'll just get read automatically the minute they find the button. And then we're going to add the hidden attribute, just the standard HTML hidden attribute, to make sure that when it's not needed, that useful information is kept out of sight. We could use aria-hidden and display none to make sure that this content was hidden both accessibly and visually, but actually the hidden attribute is the most robust and reliable way to hide content visually and non-visually, and it's much simpler to use in the long run. We're going to add a final attribute now, the aria-live attribute, and this is going to turn the useful information when it appears into a live region. A screen reader can only focus on one thing at a time, and if that thing isn't the useful part of the page, you can run into problems. So the screen reader is focused on the button, but the content that appears is somewhere else on the page, and the screen reader doesn't have any way to connect that unless we make it a live region. And that means as soon as a screen reader user activates the button, the useful information that's displayed on screen will also be read automatically by the screen reader. So it's a very usable interface for someone who can't see the content that's just appeared on the screen. Again, we're going to add the event listeners and functionality. There is a slight difference here because we are making our control a button, not a link. If you use a button element in HTML, you can use it with a space or enter keys, and again, that's the behavior we've got to mimic. So we listen out for the key codes 13 and 32 this time to make sure that they act as the trigger for the functionality. And then the last piece of functionality we're going to add in is just the ability to close the toggle tip using the escape key. So if a sighted keyboard user has moved away from the button, wants to close the toggle tip, they don't need to go back to the button to do it, which is hard work. They can just hit the escape key. So we keep things simple and usable. And then basically the functionality just says if it's hidden, reverse that, inject the content into the page, so we get into that DOM manipulation that triggers the cascade that ultimately results in the accessibility tree being updated and screen readers being informed of all the changes. And then if it's not hidden, quite simply, of course, we do the reverse. So now let's see if we can show you how this works in practice with keyboard and screen reader.
Tab, tequila button collapsed. Enter, expanded, tequila makes me happy. Escape, collapsed.
So there you can see there's a lot of information available to screen reader users. They hear it's a button, so they know it can be interacted with. They hear it's in a collapsed state, so they know it can be expanded. And as soon as it is expanded, that text is just read automatically, and then the button's just closed using the escape key. But again, we could just use HTML. So actually, we could have used a button element, an aside element, which is equivalent to the role of complementary, and accomplished much the same thing, but with, again, quite a lot less code. But we live in the real world. The last design pattern I want to touch on is one that we come across a lot in my line of work in accessibility, and that's tab panels. It's actually been the subject of a fairly furious debate recently, but it's a useful design pattern if you have a lot of content to fit onto one page, but you don't want to make the page incredibly long and have a lot of scrolling. So we use some pretty good HTML as a starting point in this case. We use an unordered list items containing links, and each of those links forms the tab that you'll click on or activate in order to display some content on the screen. We're just going to use some divs as the corresponding div panels that you want displayed when you've selected one of the tabs. So we've got some pretty good skeleton HTML there. But this is what happens when you use a screen reader to interact with the tabs based on this code alone.
Page tab. List of 3 items. Same page link blanco. Same page link reposado. Same page link Joven. Enter, Joven same page link. List end. Blank. Joven tequila is ...
So there's some information in there. We heard there was a list of 3 items, we heard that there were links, and then we heard that there was some content. But I don't know about what you think, but to me, that didn't tell me anything that suggested I was dealing with a set of tabs on screen. There was nothing to indicate what kind of visual interaction was taking place, or pretty much any other kind of interaction. Even just clicking on that link, it might have been expected that I was just taking into content further down the page rather than changing one piece of content out for another visually. So it works, but we can provide a lot more information to make things more usable. And again, we can use some role attributes. We use a role of tab list on the unordered list and a role of tab on each of the links. So again, in the DOM, this is still your regular unordered list items and anchor tags. But in the accessibility tree, this is now announced as a tab list, a collection of tabs, in which there are one or more tabs. And that information will get picked up by screen readers and communicated to the users. So we're starting to inform people about what kind of design pattern, what kind of interaction they can expect when they use this widget. We're also going to use a role of tab panel on each of the divs that contains the corresponding content. And again, this just makes better information available to screen readers. So instead of just having a random piece of seeming content on the page, they'll now know that this content is a tab panel and that it relates to the tabs that they've just been using. We're going to add the Aria Controls attribute, Aria-Controls, and this goes on each of the links that is the tab. And it creates a relationship between the tab and the tab panel. So Aria Controls just takes the ID value of the corresponding tab panel as its value. And what this does is when one of these tabs is selected, some screen readers make a shortcut available so you can jump straight from this tab into the corresponding tab panel very, very easily and quickly. We're going to use Aria-selected again on each of the tabs. For the currently visible tab, we're going to set it to true. And for all others, we're going to set it to false. And as the user interacts with this widget, those attributes across all the tabs get updated. So only one at a time should ever have a value of true, and all the rest should automatically then be updated to false. We're going to use our old friend, the Tabindex attribute, but we're going to use it in a slightly different way this time. When we looked or listened to the screen reader example from before, it was necessary to tab from each of the tabs to the next. And this, I'm sorry, is where the language gets confusing. Tabs and tabs confuse the best of us, I'm afraid. But in this case, what we want to do is just have a keyboard user use their tab key to move on to the currently selected tab, and then use the arrow keys to select a different tab, to cycle between the tabs. If they press the tab key again, we want their focus to move back into the content. And so to do this, the element that has Aria selected equals true should also have a tab index of 0. All the rest should have a tab index of -1. And tab index -1 will take something out of the keyboard sequence completely. You can still focus on it using scripting, but you can't focus on it using the tab key from the user's point of view. And this is known as a roving tab index. So we make the set of tabs just a single tab stop on the way through the page. Again, we use the HTML hidden attribute to make sure that all of the rest of the tab panels that are not currently selected are hidden away, and that's pretty straightforward. And we use another Aria attribute, the Aria labeled by attribute. And we use this on each of the tab panels, and we use the ID value of each of the tabs. And this just gives the tab panel a name. Just distinguishes it from any other tab panels that might be on the page. And you'll see how this comes together from a screen reader user's point of view in just a moment. Lastly, we're going to add that keyboard interaction I mentioned, so that once a user uses the tab key to move on to one of the tabs, they can just use left or right, up or down, to cycle through the different tabs that are available. And as each one is selected, that corresponding content is visually displayed on the screen. So this is how it all works in practice, because there was a lot of changes in there, but it really makes quite an amazing difference if you happen to use a screen reader.
Tab, blanco tab selected, use JAWS key plus Alt plus M to move to controlled element, 1 of 3. Reposado tab selected, use JAWS key plus Alt plus M to move to controlled element, 2 of 3. Joven tab selected, use JAWS key plus Alt plus M to move to controlled element, 3 of 3. Move to controlled element, tab panel. Joven tequila is ... Tab panel end.
So there's a lot more information there, and if you're listening to a screen reader here for the first time today, don't don't panic if none of that made any sense whatsoever. Trust me, for those of us who do use screen readers, that was a distinct improvement, because as soon as we started using the widget, we knew it was a collection of tabs. We knew there were 3 tabs in the collection. We were told, as we selected each one, that it had become selected, and that there was a keyboard shortcut available if we wanted to move from there straight into the tab panel. As soon as we did that, the tab panel start was announced, the content was also announced, and then the end of the tab panel was announced. So although it seems like a lot of information, and for some people it surely is, it's actually really useful information because it's a much more accurate representation of what's visually put on the screen. So quick and dirty accessibility mechanics, what do you need to think about? Well, use HTML if you can. If you can't, then remember that you need to make things focusable with a keyboard. And just try this for yourself. If you're building applications, unplug your mouse, see if you can focus on the things that you need to. Then check to see whether you can use the things you need to. Do you have the interaction available on a mouse as well as on a keyboard? And again, just try it for yourself. It's as simple as that. And do you have the semantic information you need? Do screen reader users know what the purpose of the thing they're dealing with is, or what it's going to do, or what state it's in? There are really good screen readers now, free for every platform, so if you fancy having a go, if you have an Apple product, the screen reader is VoiceOver. You can hit Command F5 to turn it on or off on a laptop, triple-click your home button on an iDevice. If you're using Windows, particularly Windows 10, narrator can be turned on using Windows key and Enter, and turned off in the same way. And that too is a really good screen reader, especially if you're curious to see how Edge is doing with accessibility. It's actually doing an incredibly good job, but Narrator is the only screen reader at the moment with good support for it. So have a go. Don't make serious decisions based on what you find, but just experience some of this, and if you can fix a few things along the way, then you won't be too far off. Just to finish off, if you want to get any of the design patterns I've mentioned here, there are a few more there on my GitHub site. There is also an authoring practices guide being developed for Aria 1.1, and it's not quite finished yet. There's already a lot of useful information, but in due course, that'll have working examples of these design patterns and many, many more. So a good place to go if you're looking for ideas on where to start with coding accessibly. And that's me done. Thank you very much.